Demand for clean and effective energy systems is a worldwide priority. Consumers and companies understand the grave impact outdated energy systems, including electric utilities, can have on the environment, and the financial strains they place on our pocketbooks.
Key issues in energy today is not only the need for more energy. As the utility grids age, we have an issue with the aging infrastructure, so we need more energy, we need clean energy, and we replace the infrastructure we have today. One nice thing about Capstone turbine is that turbines are small, they can be retrofitted into small spaces or existing architecture, so therefore alleviating the grid interconnect issues and the capacity issues with the grid. So Capstone turbine gives you not only clean energy, high efficiency energy, and the ability to place it in areas where the grid is constrained.
Well, we're seeing a trend, I think, today in the businesses in general and large businesses that require systems like this to go to a much more efficient system to reduce their costs and to maintain a greener and more efficient system. Environment is a big concern for a lot of large businesses, as it is for us. We wanted to make sure that the system that we installed when we built the building provided not only the needs and the requirements of cooling and energizing the building, but also of leaving as little bit of a carbon footprint on the environment.
Although many understand the energy problems, they aren't aware of advanced technologies that can radically change our world.
Several different applications worldwide or globally for our product. They can be used mostly in prime power applications, where we are the primary source of power generation for a facility. That can be running on natural gas, landfill gas, biogas applications, cow manure, pig manure, as well as agricultural waste. In addition, we can do coal seam gas, coal mine methane, or coal seam gas coming off of drilling operations. So multiple fuel flexibility, as well as liquid fuels, diesel, biodiesel, ethanol, kerosene. So very fuel flexible, very clean for prime power applications. In addition, we can do combined heat and power, where we take the heat off the machine or the raw exhaust to provide heating for the facility, or put it through what's called an absorption chiller to provide chilling or air conditioning for that space. In addition, the turbine can actually be used in a backup power application as well, where it runs continuously in parallel with the grid and is continually sensing the grid for an outage situation or any kind of fault in the grid. If it senses an outage or a fault, it will shut down the machine and restart the machine in a standby power or standalone application, thus providing 24/7 clean energy, reliable energy, but then also providing backup power for that installation.
A lot of people didn't know about this system when we first installed it, and there's a lot of people still don't know about turbine systems. And we had some questions about the efficiency of the system, how well it was going to provide us our electricity, hot water and cold water out of one package. After 3 years of having this system installed, we've now learned that the system does give us the efficiency that we were looking for. It's a clean burning system. It does give us all the power for the entire campus. The chilled water capabilities and hot water capabilities are what we had anticipated from the manufacturers and from the engineers who put it in.
Capstone Turbine Corporation is a leader in providing technology to meet the world's growing energy demands. The Ronald Reagan Library in Simi Valley, California, gets 95% of its electricity from 16 Capstone microturbines.
In general, a microturbine is very similar to a commercial aircraft engine. We're taking fuel in for the combustion process in a lean combustion mixture combined with air. We ignite the fuel and provide heat to spin the turbine. What's a little different about our turbine, it has what's called a recuperator, or it's an air-to-air heat exchanger. So we take the heat off the exhaust from the combustion process and preheat the incoming air. That provides higher efficiency to the turbine and better fuel economy. So overall, an unrecuperated turbine would be in the 15 to 20% fuel economy or efficiency range. We get up to over 34% with our C200 product with a recuperated version. So very similar to an aircraft turbine. It's turning at 96,000 RPM, one moving part, air bearings, no oil, no antifreeze. So highly reliable, very simple design, but with the recuperator we see much higher efficiencies than other products in the market today.
The turbines use natural gas, which is a very clean fuel. They burn natural gas, which runs the turbines, which gives us up to 960 kilowatts of electricity. That exhaust gas from the turbines running is collected and goes into an absorption chiller. That chiller has a closed water loop through it, which chills, and that gives us our cold water for our air conditioning system. Some of the turbines also have a hot water loop on them, which the exhaust gas goes through prior to going into the chiller, and that heats the hot water, which gives us the heating capability for our building as well. All three of those, the hot water, the cold water, and the electricity, all come out of this one plant and provide the entire campus with chilled water and electricity, and in a very efficient package.
The Capstone microturbines also have reduced Reagan Library's energy costs about 10% on average each year. Just one more reason the library is pleased with the installation.
The benefits of a microturbine to a business is we can provide energy or electricity cheaper than they can buy it from the grid. So we can use commercial fuels like natural gas to fire the turbine and produce electricity cheaper than we can do with the grid. What's even better is we can take the heat off the machine to offset the boiler loads or the building loads that they currently have, as well as air conditioning loads if we use an absorption chiller. So we go from 30% efficiency, which is similar to the grid, to 85 to 90% efficiency, which is much, much higher. So your economic payback for the project can be as low as 3 years, as long as probably 7 years. But in addition, you have cleaner power, lower carbon footprint, and you've got long-term economic benefit of producing your own power, heat, and cooling.
Capstone Turbine Corporation, working to keep our planet clean.